In this video, we're going to take a look at our first example of drawing circuits and applying Ohm's law to a greater circuit. So this is the first example in the series and parallel circuits practice. And the first thing they're going to ask us to do is to draw a circuit. So if you look in your notes, you can see all the different symbols for circuits. And in this particular circuit, we have a circuit with a 20-volt battery, and we're going to add a switch, a 10 ohm, and a 30 ohm resistor to this circuit. We're going to put an ammeter in this circuit, and we're going to add a voltmeter to measure the potential differences across each of the circuits. So let's go, and we're going to start with drawing our power supply, which is our 20-volt battery. To draw a 20-volt battery, we have a series of unequal lines, and I'm going to label it right off the bat with 20 volts. Now they ask us to put an ammeter in the circuit, so we're going to make sure that we don't forget that, or the switch, so I like putting those early. And the switch looks like an open bridge, and these solid lines represent wires. The A with the circle on it is our ammeter, and so we put our power supply, that's the 20, our switch, which is the open gate, our ammeter, and now we need to put a 10 ohm and a 30 ohm resistor in there. So there's a symbol for the first resistor, there's a symbol for the second resistor, and then I need to take the circuit back to its source. I'm going to label my resistors. This one will be 30 ohms, and the resistor over here will be 10 ohms. And now I have to put a voltmeter across each of these. And the voltmeter is the V with a circle around it. And we attach our voltmeter and I erased that last wire, so let me just draw that back in. We attach our voltmeter to either side of our resistor. And there we have our series circuit diagram. Note that it is a series circuit, that the current and the flow of current from the 20-volt power supply can only move in one direction, right? There's no splits down the line. What I'd like to do now is I'd like to go ahead and start going through these questions. So let's look at question A, which asks, what is the total resistance in this circuit? Since it's a series circuit, the total resistance is going to be the sum of the individual resistances. The only thing that gives us resistance in this circuit is our 10 ohm resistor and our 30 ohm resistor. So we'll say the equivalent resistance of the circuit is going to be equal to the resistance of the 10 ohm resistor plus the resistance of the 30 ohm resistor. And that's just 10 ohms plus 30 ohms, and we get a total resistance of 40 ohms. The next thing they're going to ask us for is what is the current flowing through the circuit. Now, since it's a series circuit, all the current is going to be consistent throughout the whole circuit. So when we're looking at this, we're going to consider the equivalent resistance of the circuit and the voltage supplied at the power supply in order to figure out what the current is. And we're going to use Ohm's law. And Ohm's law so that the potential difference is equal to current multiplied by resistance. And we have 20 volts of potential difference in our circuit given at the power supply. I want to find what the current is, and my equivalent resistance is 40 ohms. And that's going to give me a total current for this of 0.5 amps. Now let's take a look at the potential difference across the individual resistors. So we have a 10 ohm resistor and we have a 30 ohm resistor. And the potential difference, or the voltage drop in here, is going to be different. We're supplying 20 volts of potential difference at the power supply, and as the current moves around the circuit, it's going to drop off its energy at all the resistors. So between the 10 ohm resistor and the 30 ohm resistor, they're both going to take a portion of that total 20 volts. In order to find that, we're going to apply Ohm's law. And you can apply Ohm's law to any point in the circuit, the whole circuit or individual parts of it. So what we're going to do is we're going to find the potential difference at the 10 ohm resistor, which is going to be equal to the current passing through that resistor multiplied by the resistance of that resistor. So my voltage is going to be equal to current is half an amp, and the resistance of that 10 ohm resistor is 10 ohms. So that means our total voltage across that one is going to be 0.5 times 10, or it's going to be 5 volts. And we're going to do the same thing for the potential difference across the 30 ohm resistor. It's going to be current multiplied by resistance. And our current is half an amp. And the resistance here is 30 ohms. And if we do 0.5 times 30, we end up with a total voltage there of 15 volts. And notice that the 5 volts and the 15 volts are equal to the 20 volts we started with. So the voltage starts at the power supply, and then as we move through all the individual items, the voltage drops across each resistor. If you did a loop at any point along the circuit, you're going to find that the total voltage, if you go in the circuit, 20 adding, the two resistors taking 20 away collectively, so any loop will give us a total voltage drop, or a total sum of voltage of 0, and that's Kirchhoff's loop law. And now we're going to look at part E of here. It says, in a series circuit, components with more resistance require, well, our 30 ohm resistor took 15 volts, where our 10 ohm resistor only took 5, so that would mean that the greater the resistance, the greater amount of potential difference drop we'd have at that resistor.